Good morning. This video is going to introduce the topic of statistics and give you a survey of a lot of the topics that we're going to be covering this quarter. So let's begin with a definition of statistics. So what is statistics? The way I like to think about statistics is it's really the science of using data to make better decisions, to solve problems, to design better products, to improve our processes. So we're using data to solve a problem. Now, what does that specifically involve? Well, it involves many different things. So the first thing it involves is often, how do we gather data? So there are entire subfields of statistics devoted to this question. For example, there's an area called the design of experiments, otherwise known as DOE, which is specifically concerned with how can I design a test of some hypothesis. So can I establish that if I do something, something else is going to happen? That's that's in a nutshell what design of experiments is about. Is a structured process of designing that test. There's another subfield of statistics called survey sampling, which is about how do you design surveys that will gather representative samples from some population. That's not all statistics is about, though. Once we have data, we have to do something with it. And so that I'm going to just call the analysis of the data. So one topic that we're going to spend a lot of time with is the statistical model. So statistical models give an explanation for the data that we've observed. So we're going to be giving some mathematical formula that explains the data that we've observed. So that's an example of analysis. Is we're going to be specifying that model and estimating the parameters that are part of that model to help us with our problem solving. Another thing that we may be doing is just describing some population with various statistics. So, are the people in this community old? Are they young? Are they all young? Are they all old? Those are descriptive tasks that are involved with analyzing a data set. There are also a lot of algorithms that are used, machine learning algorithms that I would put under analysis. So if I've gathered data on a lot of images, and I need to classify those images, the analysis of those images you could think of as a statistical analysis task. All right. Finally, statistics also deals with the presentation of evidence. So we don't do analyses just for the sake of doing analyses usually. We're doing this in service to informing some problem or decision that we're trying to make. And often we're dealing with stakeholders that are not statisticians. So how do we communicate what the data is saying? How can we communicate the evidence in a clear and compelling and honest way? That's also what statistics is concerned with. The other terms on this slide are part of the statistics vernacular that we're going to be using throughout the course. So the first of these terms is a unit or unit of analysis. So this is a generic term that we're going to use for the thing that we're studying. So what is this entity that is under study right now? And so, for example, maybe we have we've just manufactured a bunch of parts for some customer, and we've manufactured, say, 5,000 parts in this order, and the entity that we would be studying would be the part. Okay, so there's a group of parts that we've just manufactured. The entity is a part. Alternatively, we may be doing some sort of a public opinion poll. Okay, so I want to understand what the citizens of some country feel about some policy. Okay, in that case, our unit would be a person or an individual. Sometimes you'll find studies of companies. So maybe I have studied a bunch of companies and measured their practices. And so in that case, my unit of analysis will be the corporation. I'll just mention that sometimes we modify the term unit. For example, in experimental design, we study experimental units, or in survey sampling, we call it a sampling unit. But this is just the generic term that we use for the entity we're studying. Okay, in statistics, we start by defining the collection of all units that we're interested in. And that collection is usually called the population. Sometimes it's called the universe, depending on how the person you're talking to was trained. So some people call it universes, others call it population. They mean the same thing. So in the case of my my manufacturing example, we just made 5,000 parts for some customer. The population would be all 5,000 parts. In the case of my public opinion poll, it would be all citizens who live in some country. So that could be the population in that example. If I'm an epidemiologist, maybe I care about all the people in a country. So that would be the population that we're studying. Now, there's usually some numerical fact about the population that we care about. And so that numerical fact is called a parameter. Models are also going to have parameters that we're going to be interested in. So what's an example of one of these numerical facts? Well, one numerical fact could be, say, the mean diameter of the part that I've just produced. So if I could measure every one of my 5,000 parts that we've just manufactured for this client, I could compute the mean and I would know the parameter. Now, a slightly different version of this could be maybe certain diameters are within tolerance and therefore they're okay. Other diameters are out of my specified tolerance range, and therefore I deem them to be defective. Okay, so a parameter could be the percentage of defective parts in this batch that I've just produced. In the public opinion poll, it could be the percentage of everyone in the country who favors some policy. In the epidemiology example, it could be the percentage of people who have some disease or have already had it and are immune to it. So that would be the parameter. Now, how do we gather information about the parameter? The answer is we're going to use what is generically called a survey. So by survey, I mean some systematic process for gathering information about the units in a population. There's an important distinction between survey methods. So one type of survey is called a census and another is called a sample. So with a census, we are going to measure all units in the population. So in my manufacturing example, if I were to measure the diameter of all parts I just manufactured, I have done a census. It's great to have a census, but there's a couple problems with censuses. So first off, they are very expensive to do in a lot of settings. So the classic example of a census is when a government attempts to measure every person living in its country. So the U.S. does that every 10 years. Other countries do it, roughly the same, every 10 years or so. And of course, it's very expensive to gather information about every person living in your country. There are many populations that are just hard to reach. Homeless people are hard to find. People who live on Indian reservations may be very difficult to survey because they don't have easy mailing addresses, or they're not connected to the internet. So for all these reasons, censuses can be very expensive to do. With that said, more and more stuff happens in digital environments where things just get measured during that, in that environment. So often we have censuses where, today when we're manufacturing parts, a lot of things get recorded that were not so easy to record in the past. With that said, beware of what I'm going to call a sloppy census. So I'll give you an example of a sloppy census. We may think that we have a lot of data because we have the responses of all Twitter users. We think, wow, I have the responses of all Twitter users. I can tell you what all Twitter users are saying about my product. And I think that's a census, but it's not really a census because this group of all Twitter users doesn't match up with the population that I'm interested in. So if my population is all of my customers, not all of my customers are on Twitter. So just because you have a big data set with measures from everybody in that measured group, like all Twitter users, that doesn't mean that it matches up with everybody in your defined population. All right, so for one reason or another, we may not want to do a census. Instead, we'll do a sample. So by sample, I mean some set of units in the population, and I'm going to take measures of those units. Now, often a census is not as accurate as a survey sample. So as an example, if I'm going to try to measure everybody in a country, and if I don't have the resources to really do a thorough job of gathering information on homeless people, gathering information on people who live on Indian reservations, I can actually get a more accurate picture of what's happening in a country by doing a carefully designed sample where I'm not going to try to measure everybody living on Indian reservations, but I use a careful procedure to draw certain people living on the Indian reservations and use that to make inferences about others. All right, so that's what samples are about, is just designing procedures to gather some units. Now, not all samples are good. We'll talk about something called a convenience sample. So convenience sample is where you just gather information about sampling units that are convenient to you, and those may not be representative of everybody in the population. So, my Twitter example is really an example about a convenience sample where it sure is convenient to look at what people on Twitter are saying about my product, but that doesn't represent everybody. So that would be a convenient sample. All right. Another term that we're going to need is the statistic. So beyond statistics as a field, a statistic is just some numerical fact that I've computed from my sample. Now, I use this statistic to approximate my parameter. So let me give you an example. Maybe I don't want to measure all 5,000 parts that I just manufactured. Instead, I draw a random sample of 100 of those parts and measure them. Okay, so if I measure the diameter of the 100 parts I just manufactured, then that is, the mean diameter of those 100 parts would be a statistic. That is going to be my best guess at the parameter, which would be the mean diameter of all 5,000 parts. Okay, so we're going to talk a lot more about statistics as we go on. At this point, you might want to apply these terms to the following setting. I'll get you an answer to this in class discussion. Okay, we need a few more terms. What does univariate mean? Univariate means one variable. So univariate analysis means we're analyzing one variable at a time. This is contrasted with bivariate methods, where we're studying two variables. So for example, if I correlate two variables, that would be a bivariate analysis. If I run a simple linear regression where I study how y depends on x, that is a bivariate analysis. Another whole field of statistics is called multivariate analysis. You can take a course in that, where we're studying two or more variables. So multiple regression would be an example of this. There are many other examples. If we do principal components analysis where we reduce the dimension of a data set, that's a multivariate analysis method. All right, so we'll use those terms. What is a descriptive statistic? So descriptive statistics is a class of measures that describe some batch of data. So I use the term batch so that I don't have to call it a sample or population. So this is John Tukey, very famous statistician, used the term batch, and I'm going to follow his lead. So I've gathered some data. I don't care if it's a census or if it's or if it's a survey. Now I want to describe it. So what do I mean by describing it? Well, we're going to go over these measures this week. You've probably seen these before, but there are various aspects that I may want to use to characterize my my variable. So I'm just going to go over and draw some pictures for you. One way to describe a batch of data, is to look at the shape of its distribution. So does it have a normal distribution where it's this familiar bell-shaped, or is it skewed? So that would be an example of a skewed distribution where most of your values are small, and then you have some values that are extreme. So that's an example of describing the shape of data. I could also have a bimodal distribution. So this would be an example of a bimodal distribution where I've got a bunch of large values and I have a big clump of smaller values and not as many in the middle. So I've described the data. Another thing that we may want to do is to characterize specific attributes of this. So where's the middle of this distribution? Well, that's the middle. I should have drawn that a little bit straighter. Let's draw it straighter. That would be the middle or the center. And so then we could often say, is the middle of this distribution greater than the middle of this distribution? And, we could use descriptive statistics to make that comparison. Another thing that we may want to ask is how homogeneous is this population? So if this is the population versus another population, I'm going to make it much more dispersed. We would say there's much more heterogeneity in this group than up here. These people are much more consistent. These people are all over the place. Okay, so that's a measure of dispersion. So how dispersed is the population? And so we often care about these things. So where's the center? How dispersed is it? Is it skewed or is it symmetrical? How many modes does it have? So a mode is just a local peak in this picture. All right, so that's what I mean by descriptive statistics, where I'm attempting to describe the distribution. Another term that we have is inferential statistics. So inferential statistics are the study of using a sample to draw conclusions about the entire population. So one of the most profound results that we're going to have is being able to quantify how far our statistic is from the parameter. So if I've done a public opinion poll as an example, where maybe I've sampled 1,000 people and asked them whether they favor the policy, I can make inferences about how far that statistic, so the fraction from my sample, is from the population parameter. If I interviewed everybody, and I think it's really just profound that we can make those inferences about how far my statistic is off from the parameter. A couple more terms. Exploratory studies are where we start with a data set and we don't really have any specific hypotheses in mind. We may be using the data to generate hypotheses and get insights about what's happening. This is in contrast to what's called a confirmatory study, where we begin with a testable hypothesis, we design some test of that hypothesis, and then we go out and gather data. So we start with hypothesis and then gather the data. That's what confirmatory studies are going to be about. A few more terms. For those of you who've had stats, and I suspect most of you have already taken a course in stats, these symbols will be familiar to you. If you have never had a stats class before, don't worry about it for now, but just to kind of connect with what you're already used to. These are some common parameters in statistics. So when we're talking about the mean diameter of all parts that we made, that's going to be a mu. If I measure 100 parts and compute the mean, that would be an x bar. Likewise, sigma is the population standard deviation, S is our sample standard deviation. All of these are going to be defined in various parts of my course packet. Okay, few more things. I think students often have a difficulty in statistics because of the language. So there's a lot of terms that get used in very specific ways, and students don't always understand the exact meaning of a term. So a lot of these terms also have sort of common everyday meanings that are not so precise. So we're going to use this convention that we're going to prepend either the word population or sample to refer to these things. So if I ever say population mean, what I'm referring to is mu. If I say sample mean, I'm referring to x bar, the x with the line over it. Likewise, population percent versus sample percent. One more thing to be aware of, not every textbook author agrees on these symbols. And therefore, if you've had a previous stats class, the terms that get used, the symbols that get used may not be exactly the ones that your previous textbook used. I've been teaching this course from another textbook, not DeVore. And so at some points in my video, I may be using some of the notations from the other textbook rather than this textbook. So I'm just going to make you aware of some of the most problematic cases. So A lot of textbooks will use pi for the parameter and p for the statistic. Some books use p for the parameter, p hat for the statistic. Some textbooks will use alpha for the regression intercept when we get there, and so forth. So just beware of those issues. I hope that doesn't create any confusion for you. All right, that's it for the basic definitions.